So, happy Monday. Unfortunately, I'm not here today because I'm in meetings all day. So, I'm not just skipping school and enjoying a day off. You guys are probably having more fun than I am. But even though I'm not here, we still have to learn today because we got lots to get through. So, today we're moving on. So, today it's still chapter 5, but section 5. And we are thinking back to our favorite topic this year, which was factoring. Hooray! So, remember that we factored so that we could find the zeros. So the zeros are where we cross the x-axis. So we did this with quadratics. Remember, quadratics look like these U-shaped things. So we had these U-shaped things, and we would factor so that we could figure out where does that quadratic, where does that parabola cross the x-axis. So we said, like, okay, we factor it, and then we find out that it crosses at those 2 points. All right, so we factored in order to find the zeros of quadratics. Well, now we're working with polynomials that have lots of curves in them, and we want to be able to find the zeros without having to use Desmos all the time. So what if we had something that looked like this? What if we had this graph, and I want to find these points? I want to find these zeros. There's more than just 2 of them now. So what if we have a graph that crosses the x-axis a bunch of times, and we want to find all those points where it crosses the x-axis? So we can still do this by factoring. But first, as a warm-up, let's remember how to factor. So let's just factor quadratic. So this is a U-shaped graph. It'll cross the x-axis 2 times. So let's figure out where does that happen. So think back to factoring. There's a couple things we have to do. First thing that we have to do is find 2 numbers that multiply to a times c and add to b. So write that down. So we need 2 numbers that multiply to a times c and add to b. So remember doing this little trick where we have to draw 2 lines coming out and do 2 times -5, which is -10. So we need 2 numbers that multiply to -10 and add up to +9. So start listing out numbers. Start listing out numbers that multiply to -10. So we could have 10 and -1. And in this case, we got lucky. Those are the 2 numbers that work. 10 times -1 is -10. And 10 plus -1 is 9. So our 2 numbers are 10 and -1. Once we find them, we always take the 2 numbers and plug them in for that middle term. So instead of a 9x, we're going to write 10x minus 1x. So this middle term gets erased, and it gets replaced with these 2 things instead. So we will have we will write 2x squared plus 10x minus 1x and then minus 5. So all that we did is replace this middle number with these 2 numbers that we just found. Okay, once you do that, we group it. First 2 and last 2. Remember doing this? So group the first 2 numbers and group the last 2 numbers. And then we take out the greatest common factor of each group. The greatest common factor is a number small enough to evenly fit inside of both numbers. You can only take out an x if both terms have an x on it. So here we cannot take out an x because this 5 doesn't have an x. So the greatest common factor of 2 and 10 is 2. And the greatest common factor of x squared and x is just an x. You always take the lower power. So 2x. Left inside, we would have 2x times what would give me back 2x squared? And the answer is x. And 2x times what would give me 10x? And the answer is 5. Then we do that same thing for this second set of parentheses. The greatest common factor of -1 and -5 is just -1. If the leading number is a negative, you have to take out a negative. I cannot take out an x because this 5 does not have an x on it. So I take out just a -1. If the leading number is negative, take out a negative. Left inside, -1 times what would give me -1x? And the answer is just x. And -1 times what would give me -5? And the answer is +5. Oh, jeez. Oh, excuse me. All right. So the last thing that we have to do is, well, actually two things. Make sure that our parentheses match. If your parentheses match, then you know you did it correctly. Are these the same? Yes. I have x plus 5 in both of them. So our last step is to clean this up. So we combine the things on the outside of parentheses. So the 2x and the -1, the things on the outside of parentheses, we combine those together. So we will write 2x minus 1. And then we bring down just one of the sets of parentheses. So bring down x plus 5. At this point, we are factored. Okay, so now we are going to move on and we're going to factor larger things. We're not just going to factor quadratics. Remember, a quadratic means it's degree 2. That means that it's a U-shaped. We're not only going to factor quadratics. Now we're going to learn how to factor larger polynomials, something that might look like this. So, some notes. We can also factor polynomials that are higher than degree 2. So that means they are larger than quadratics. So we can also factor other things, not just quadratics. We can factor bigger polynomials. To do this, we use the same method though. It's called the grouping method, where we group the first two and the last two. It's the same method, just a little bit bigger numbers, but it's not much more difficult. You'll be fine. So, if we are given a polynomial with 3 terms, like the warm-up, so here in the warm-up, we had 1, 2, 3 terms. If we're given a polynomial with 3 terms, then we must replace the middle term with 2 numbers that multiply to a times c and add to b. Okay, so why do we do this? We do this because before we factor, we like to have 4 terms. So in the warm-up, we were only given 3 terms. 1, 2, 3. But once we replaced that middle number, now we had 4 terms. So if you only have 3 terms to start off with, then you have to replace that middle number
with two numbers that multiply to a times c and add up to b. We like to have four terms before we factor. What about if we're already given four terms? If we're already given four terms, it's actually a little bit easier. So if we're already given something like 2x cubed plus 4x squared plus 6x plus 3, if we're already given something that has four terms, now this becomes easier. If we're already given something with four terms to start off with, then we can go straight to the grouping method. We already start off with four terms, then we don't have to find two numbers that multiply to a times c and add up to b, all that stuff. All we have to do is go straight to the grouping method. So I'll show you an example of that in a second. Two things to remember. Number one, always take out the greatest common factor first. Always look right away from the beginning, is there a greatest common factor to take out? That's the first thing that you need to do. If there is a greatest common factor, take it out. Number two is if we only have three terms, you must always replace the middle term and your parentheses must match. So, if we start off with only three terms, we must replace middle number with two terms, so we have four terms. Draw the R. There we go. So, if you start off with only three terms, you have to find two numbers that multiply to a times c and add up to b, and replace those two numbers with the middle number, because we always want four terms before we factor. Also, a little star, you can put that remember your parentheses must match. Okay, so we're going to do a couple examples. Then you are going to try a couple examples on your own and make sure that you check the answer key on Blended Schools. All right, on to the next page. So we're going to factor the following polynomials. This first example only has three terms. 1, 2, 3. I want four terms before I factor. So this is where we have to do a little bit of the extra work. We need to multiply. Actually, first thing that we always have to look for. First thing we always have to look for is a greatest common factor. So is there a number that can evenly fit inside of all of these? In this case, yes. 2 evenly goes into all of these numbers. Also, all of these numbers have an x on them. So we can take out front, right from the beginning, a 2x. So take out a 2x. And now rewrite this thing. So 2x times what would give me 12x cubed? The answer is 6x squared. 2x times what would give me 10x squared? The answer is 5x.
And then last thing, 2x times what would give me negative 8x? The answer is negative 4. Okay, once we have our greatest common factor, which is this 2x, forget about it until the end. Tack it back on at the end. For now, we have to just factor our new, smaller polynomial. Once again, we only have 3 terms. I want 4 terms. So to get the 4th term, I have to replace the middle term with 2 different numbers. So I have to do a times c, so 6 times negative 4, which is negative 24. I need 2 numbers that multiply to negative 24 and add up to 5. So start listing out numbers that multiply to negative 24. I could do 1 and negative 24. Those don't add up to 5. I could try negative 2 and 12. Those multiply to negative 24, but those don't add up to 5. I could try negative 3 and 8. Those multiply to negative 24, and those also add up to 5. So these are my 2 numbers that work. So rewrite this expression now, replacing the 5x with negative 3x plus 8x. So we're going to rewrite this. So it becomes 6x squared. And then instead of plus 5x, I'm going to write minus 3x plus 8x, and then minus 4. Okay, the reason I did all this was because I now have 4 terms. 1, 2, 3, 4. Earlier, I only had 3. I started off with only 3, but I want 4 before I factor. Now that I have 4 terms, I can group it 2 and 2. So group first 2 and last 2. And now take out the greatest common factor of each group. So the largest number that fits into 6 and negative 3 is 3. Also, they both have an x, so I can also take an x out front. Left hand side, 3x times what would give me 6x squared? And the answer is 2x. 3x times what would give me negative 3x? And the answer is negative 1. Okay, now take out the greatest common factor of 8x and negative 4. Our leading number is positive, so we will take out a positive number. The largest number that fits inside of 8 and 4 is 4. I cannot take out an x because this does not have an x on it. So all I can take out is a 4. Left inside parentheses, 4 times what would give me 8x? The answer is 2x. 4 times what would give me negative 4? And the answer is negative 1. Check. If you did it correctly, then your parentheses will match. Do they match? 2x minus 1, 2x minus 1. Yes, they do. So the last step, clean it up. So we have 3x and 4, so put those together. And then bring down your parentheses, 2x minus 1. Now I'm forgetting something here. What am I forgetting? Remember, in the very beginning, we took out a greatest common factor. Make sure that you tack that on as well. In the very beginning, we took out a 2x. Make sure you tack on that 2x. At this point, we are done. All right, let's move on to the second example. Here, I want to factor this thing. This will be easier. Look, there are already 4 terms to start off with. In the first example, we only started off with 3 terms, so we had to do a little bit extra work. Here we already have 4 terms, so I don't have to do all this stuff here, the whole multiply a times c. If you have 4 terms, then you can go straight to grouping. But remember, always look for greatest common factor first. These have 1's in front of them. 1, and here's a negative 1.
So the biggest number that would work is 1, and it doesn't help to take out a 1. But they also all have an x on them. So we can take an x out. Since this is x to the fourth, x to the third, x squared, and this is really x to the first, you always take out the lowest power. So all we can take out is an x. So take an x out front and then rewrite this.
So this becomes x times what would give me x to the fourth? The answer is x cubed. X times what would give me negative x cubed? The answer is negative x squared. X times what would give me negative 25x squared? The answer is just negative 25x. And x times what would give me 25x? And the answer is just 25. Okay, at this point, we have 4 terms inside the parentheses. 1, 2, 3, 4. Forget about this greatest common factor until the very end. Tack it back on. But for now, we have 4 terms already, which is nice. So we don't have to do the whole multiply to a times c and add up to b thing. Here, we can just group it, 2 and 2. If you have 4 terms, it's a little bit easier. So we have x cubed minus x squared minus 25x plus 25. Since we already have 4 terms, group it, 2 and 2. Now take out the greatest common factor of each group. The greatest common factor of x cubed and x squared. Always take out the lower power. So the greatest common factor here is x squared. So x squared times what would give me x cubed? And the answer is x. X squared times what would give me negative x squared? And the answer is negative 1. All right, now take out the greatest common factor of the next 2. The leading coefficient is a negative, so make sure you take out a negative. This does not have an x on it, so we cannot take out an x. So the greatest common factor here is just going to be negative 25. What's left in parentheses? Negative 25 times what is negative 25x? The answer is x. Negative 25 times what would give us positive 25? The answer is negative 1. Negative times a negative equals a positive. Check your parentheses. Look, they match here, so we did it correctly. So clean this up. Combine the things on the outside. So we have x squared minus 25. Bring down your set of parentheses, x minus 1. And then don't forget, we took out a greatest common factor in the beginning. We took out this x. So bring it over and tack it on as well. Okay, however, we can go a little bit further. Remember our trick. X squared minus 25. This still breaks down further. We want our final factors to only have an x in them with no powers. X squared minus 25 happens to break down easily because this has a nice square root. What is the square root of 25? The square root of 25 is 5. So this middle factor breaks down a little bit further into x plus 5 and x minus 5. So, last thing we have to do. This breaks down a little bit further into x plus 5, x minus 5. Because the square root of 25 is 5. X times x is x squared. 5 times negative 5 is negative 25. Now, bring down the x as well. And bring down this x minus 1. Now we are completely factored. All right, a quick tip is if you get a difference of squares, make sure you break it down. So, break down difference of squares. For example, if you had something like x squared minus 16, this breaks down. What is the square root of 16? It is 4, so it becomes x plus 4, x minus 4. Don't forget to break down difference, which means subtraction, difference of squares. So things that have a nice square root, break them down. All right. 2 more examples that we are going to do. So this third one right here, let's go ahead and factor this. We already have 4 terms, so this is easier. This is nice. We don't have to do the extra work here. We already have 4 terms, so right away we can group it 2 and 2. First of all, look, is there a greatest common factor? Here, there is not. These have 1s in front of them, so the largest number that can fit inside of 1 is a 1. This 4 does not have an x on it, so I can't take out an x. So there is no greatest common factor other than 1. And taking out a 1 doesn't help. So first, let's just group it 2 and 2. Since we already have 4 terms, this is easier. We can group it 2 and 2. So group it 2 and 2. And now take out the greatest common factor of each group. The greatest common factor of x cubed and x squared. Always take out the lower power. So it's x squared. Left inside, x squared times what gives me x cubed? The answer is x. X squared times what gives me x squared? And the answer is 1. Okay, what's the greatest common factor here? Since the leading number is a negative, make sure you take out a negative. Largest number that fits into 4 and 4 is 4, so negative 4. I cannot take out an x because this does not have an x. So left inside, negative 4 times what is negative 4x? So we have x. Negative 4 times what is negative 4? And the answer is 1. Check it. Do your parentheses match? Yes, they do. So I know that we did it correctly, so clean it up. So we have x squared minus 4 times x plus 1. But notice, I like my final answer to only have x, no powers. I don't want these powers. I want my final answer to only have x to the power of 1. So this breaks down further. What is the square root of 4? It is 2. So this breaks down into x plus 2, x minus 2. And then bring down this parentheses, x plus 1. This is my final answer. All right, last thing. So that was factoring. Sometimes we will have problems that say solve or find the zeros. This takes it a step further. We must factor and then set all of our factors equal to 0. We already did this problem. X fourth minus x cubed minus 25x squared plus 25x. That was the one that we did up here. So let's just bring down our final answer. So we already factored it, so we don't have to do all the work again. Let's just rewrite our final answer down here. So whenever it says solve or find the zeros, we have to factor and then set all of our factors equal to 0. So let's bring down our answer from above. So first thing we have to do is factor this. So we're bringing down this answer right here. So we have, always set these things equal to 0. So we have 0 equals x times x plus 5 times x minus 5 times x minus 1. Now you have to set each individual factor equal to 0 and solve. So first, take the first factor and set it equal to 0. X equals 0. There's no more work to do. That's it. That's one of our answers. X equals 0. Take the second factor and set it equal to 0. So we have x plus 5 equals 0. And solve. So subtract 5. So we get x equals negative 5. Take our third factor and set it equal to 0. So x minus 5 equals 0. Add 5 to both sides. So we get x equals 5. And then the last thing, take our last factor, set it equal to 0. So x minus 1 equals 0. Add 1. We get x equals 1. Okay, why did we do this? Why do we care about these? These points are where we would cross the x-axis. So make a little graph of this thing. This thing would look like this. Let's see, let's go to 5 and negative 5 on both sides. So 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. Okay, so we have zeros. So we cross the x-axis at 0, negative 5, positive 5, and positive 1. So this thing would look like this. And just like in the warm-up, when we found the zeros of a quadratic, now we can find the zeros of a larger polynomial. So, your goal now is try the rest of this packet on your own, and then check the answer key on Blended Schools. The answer key is titled 5.5 Day 1. Look at the top of your little paper, 5.5 Day 1. So do the rest of this packet, work with your partners, say hi, say good morning to each other, and then try the rest of these. Check the answers on Blended Schools. All right, guys, have a great Monday. I will see you tomorrow. Thanks.